This next presenter comes to us from Hitachi Astemo, and it's a company that I've gotten to know pretty well over the last couple of years. They've kind of found their way through how to make a lot of very interesting things happen. And today, I'm very privileged to introduce Murilo Junqueira from Hitachi Astemo to talk to us about how they're bringing machine learning into damper models using full vehicle simulation. So Murilo, the floor is yours. Thank you very much.
Hey guys, good afternoon. I was quite different on the picture, but okay. I'm speaking on the name of Hitachi Astemo. It's advanced sustainable technology for mobility. We are the integration between Keihin, Showa, and Nissin, and then we formed the Hitachi Astemo together with Hitachi Automotive Systems as well. We do powertrain systems, chassis systems, brake systems, autonomous and driving, and motorcycle systems as well. So here is a portfolio from some technologies that we provide for the OEMs. So from brakes, steering, suspension, internal combustion engine, electric engines, and ADAS as well. So talking a little bit for the work that I will present over here, it's a study that shows the application of neural network damper models on cost simulations, because most of the simulations that we run for vehicle dynamics, we use lookup tables for the dampers models that sometimes we lose a little bit of the characteristics of the dampers, like hysteresis or other kind of behavior from the dampers. But another options that we can use, they are the 1D dampers models, like from Simulink, for example, we're using fluid properties. But sometimes these kind of models, we struggle for the real-time simulations, for applying these on the simulator world that we are getting for our future. So we have been working on a machine learning damper model to bring a little bit more, enhance the experience on the simulator world on this path for virtual tuning. So as I said, we were trying to increase this usage of the better models to enhance the experience on the simulator. So as I mentioned, the tabular data, they have some good usage for steering and handling simulations. They could bring a good correlation for this kind of maneuvers when we struggle more on tires instead of the dampers proper self. But when we bring 1D models that we can enhance for ride simulations, we're still struggling with this real-time sometimes, because they are too complex and bring these fluid properties to enhance, try to get better for the dampers. So we at Hitachi, we are bringing these neural network model dampers to apply on the simulators. So the way that we prepare these kind of models, we generate a bunch of data, and then we apply for our machine damper, our deep learning model, that we have 3 layers of learning with back propagation, and then we apply some gains to do the check how is the model are behaving compared with the data that we got. And then we prepare damper model for the co-simulation by itself. So over here I'll bring one example that we had on the close past, that we had a damper model, a damper that we had on the blue lines over there, like a not usual lag on the rebound side of the damper, but on the orange lines over there, we can see how the 1D model will behave. So we are losing some of these behavior from the dampers, even using this complex model. So over here we have an example of our deep learning model that we could improve this adhesion of this on the kind of behavior, and as well on the beginning of the rebound of the damper, we also had some improvement on this. So and we were able to keep some hysteresis and keep all these behaviors of the damper using this kind of model. So one check that we need to do is when we are going to apply for real time, we need to use fixed time steps. We have like a minimum size of these time steps. So these 1D dampers, sometimes we struggle because some portions of the simulation, we need a very small time step. So here we have a comparison that we run these neural network dampers with fixed time step and variable time step, so we are not losing the response over here. We can see PSD for all three directions of the acceleration of the chassis. So we are not losing the behavior of losing anything during the simulation. So over here I have a comparison when we apply for steering handling maneuvers. We can see we almost do not see any difference because, as I said, we have here on red lines the neural network dampers, on the dashed blue 1D dampers, and the green the peak force tabular data. We see a little bit of difference on the 1D dampers. It's because we are losing this kind of lag from the damper, so we can see a little bit over-damped model, but when we compare with the peak force velocity, they are quite similar because, as I said, we had a good usage and correlation for peak force on mostly of linear handling and steering maneuvers. But when we go for ride events, for example, for lateral and longitudinal accelerations, those two plots below, we start to see some difference that we can see on the red lines, a small difference over the 1D dampers, but the big difference will come from the vertical analysis. That's mostly, most of parts of the ride metrics will come is from vertical response of the vehicle. So we will have lateral and longitudinal, but most of the subjective feeling of the driver will be on this vertical response of the vehicle. So we can see that we had now a big difference between the 1D dampers and the neural network dampers, and as well the peak force velocity dampers. So this is a small example of these, how these dampers could behave and help us enhance this kind of simulation. So we are considering that these neural network dampers, they have their benefits to improve the real-time simulations and be applied for the simulators. So we are always pursuing new kind of technologies to better align with our partners to enhance all these experience for the simulator, and as well for kind of next steps that we have, we are working with hybrid neural network damper with a 1D. It's not so complex 1D model, but we can enhance it with these neural network models and bring some uncertainties that we have on the damper models, like we can have like enhanced friction and hysteresis modeled on these kind of dampers, and as well bring like another effects like temperature effects during the drive of the vehicle. And as well, we are working to introduce these machine learning dampers on to this virtual tuning process that all the OEMs are going through. So this is what I have.
So thank you very much, Murilo. You know, the area of machine learning and AI is, obviously it's not going anywhere anytime soon, so we appreciate the time you took to put that together. Any questions for Murilo before we go on? Yes, please, Bob Powell.
You showed a difference between the 1D and neural network model, but it wasn't clear that one of them was better than the other in terms of accuracy.
Okay.
Can you elaborate?
Yeah. Because of this, how the adhesion on the football curve that we could see, we consider that the neural network damper is capturing most of these the vehicle the behavior that we are expecting to see on the model. For sure, we need to show some correlation on these with physical tests, but we consider this as the path for these kind of damper models.
So I think I'm missing something basic maybe in the presentation, like a 1D damper, you're just saying force versus velocity. And the other damper, are you saying it's a new damper technology that you're using, or it's a way to characterize a normal passive damper and you're using whatever different inputs to ultimately say how much force it's putting out?
Yes, it's not a new type of damper. It's a new way to characterize the damper and input on the models, because sometimes when we run ride analysis, you start to be so far from the subjective test evaluations that you do, or even for objective metrics that you got from vehicle measurements. Some portion of these will come from tire models, another portion of these will come of bushings, and another from damper models as well. But the damper models, the way that we just usually did on the past, that we just input the peak force values on the mid portion of the football curves, we will miss a lot of the damper behavior, like this kind of lags that we saw on the model. So this way that we are modeling, it's a better way to represent the models on the simulation NCAE models for vehicle dynamics.
Could we talk a little bit about the characterization? Like, how do you actually do the calibration for these? What kinds of tests do you have to run? How do you decide how much data is sufficient for the calibration? You know, how much do you set aside for validation? Could you talk about the calibration a little bit, please?
Yes, this is kind of our secret. Okay, but we for validation of the models and the time that we spent trying to get a better learning on our neural network model, we spent good amount of time doing sweeps, sine waves of the dampers with different strokes and velocities, but we are working for a different way to do this kind of characterization. But to try to use like a single drive profile, for example, that we can sweep a lot of different strokes and speeds of the rod to do this kind of this. Because in the beginning, when we are doing all the validation of the models, we are generating a ton of data, and it was taking more time than just swap the damper on the car for doing the post-processing, but we are now on a much better shape than that. And we can do this fast to do a proper tuning on the simulator with good speed.
Relates to a specific valving, so you are characterizing a given damper. In the process of tuning, I mean, if you are tuning dampers, are you still dependent on characterizing a certain valving, or how do you get the efficiency of being actually able to tune the damper with the neural network technology?
Okay. Yes. Most of the programs, when we start, we do based on a baseline vehicle or on a competitor, that we have an idea about how the damper, how the vehicle behaves. And we have as well models that we use to do some prediction of the pressure and flow of the damper, that these will guide us for doing this kind of tuning based on the valve types that we are doing. But we use our data that we have internally to use to feed this kind of models.
Okay, thank you, Murilo. We appreciate it. Any other questions for Murilo? We can take them offline, but I'm sure that Marcus, Omar, Claudio, and the rest of the group here, and anybody that I missed, sorry, from the Hitachi, would love to talk to you about what else they can do. So thank you very much, Murilo, for an excellent presentation.